Assalamualaikum warahmatullahi wabarakatuh. My name is MOHAMMAD Ikram bin Yazid and I am from class C7, and in this video I'll be giving my presentation on assessment for the subject MAT 455. In the first question, students are asked to find and plot the region of the graph using mathematical software like GeoGebra. To draw the graph, students firstly need to understand the equation given in the question. The equation starts from dx dy, meaning the graph is read from left to right. That means we can see that the quadratic graph with the equation of x equals to 4 minus y square can be drawn first, and then we can see the line of x equals to 4 be drawn. In solving the first question, student must start the equation integration with dx, and in some part of the calculation, student then needs to separate the equation into two because the equation is different. One of the two equations need to do integration by part. Add both equation and then finish the calculation. And after the calculation have been done, the answer will be 82.397. For the part C, student need to change the order of the integration from dx dy to dy dx. This time, the equation reads from bottom to top. In the first order, x equals to 4 minus y square, but in the second order, the equation changed to y equals to square root of 4 minus x. So, the range of dy is from square root 4 minus x to 2. And for the range of dx, it starts from 0 and ends with 4. X equals to 4. The value in second order is 82.397. Okay, next, we will be moving to the second question. This here is the 3D projection using GeoGebra of the projection of the diagram. First of all, we will be looking at the x direction or x-axis projection of the diagram. Next, we will be seeing the projection of the diagram from y-axis. And lastly, this is the projection of the diagram from z-axis. Next, the question asks students to find the volume of the object from x, y, and z axis projection. Firstly, we will be looking at x-axis. Projection from x-axis will be the plane of the object. The base will be from z and y-axis. The quadratic graph shown with the formula of z equals to 1 minus y square. The formula of integration at x-plane can be seen at the top left corner of the image, and the total formula for the volume can be seen at the bottom left of the image, and it is calculated from dx, dz to dy. Since we read the area from bottom to top, and after calculation has been done, the volume from x-axis is 8 over 15 unit cube. After that, we will be calculating the volume from y-axis. In here, y-axis will be the plane and the base will be from x and z-axis. Formula for y-plane will be y equals to plus minus square root x. To calculate the area under the graph, which is the base of the object from y-plane, we will calculate it from bottom to the top. And for the full formula of the volume from y-axis, we can see at the top left corner of the image, meaning that the final volume formula is calculated from dy to dz to dx with the volume of 8 over 15 unit cube. And finally, students need to calculate the volume of the object from z-axis projection. Projection from z-axis will be the plane of the object, and its base will be x from xy axis. The formula for the z-plane will be z equals to 1 minus x. And to calculate the area under the graph of the base, it is easier to calculate from the left to the right of the graph, meaning that student will encounter the curved line which is x equals to y square, and then they will meet the x equals to 1 graph. The formula of the volume is as follows. The volume will be calculated from dz to dx to dy, and the volume of the object from z-axis is 8/15 unit cube.